Hi guys, welcome to Physics and Fun, and today we're going to talk a little bit about something that is a crucial part of how all of us move. Next, you're going to watch 3 videos. Now, what do these 3 videos have in common? A. Current, B. Wavelength, C. Momentum, or D. Power. If you guess momentum, then you're correct. All 3 of these actions display momentum. But what is momentum? Momentum is generally described as the quality of the motion of the moving body. The equation to find momentum is mass times velocity, or m times v equals p. In physics, we use the lowercase p for momentum as the uppercase P is used for power. The equation goes to show that mass and velocity are directly related to momentum. This means that if the velocity is half its original value with the same mass, then the new momentum is half the original momentum. The units for momentum are kilograms times meters over seconds. The kilograms comes from the mass, and the meters over seconds comes from the velocity. Momentum is a vector, so you have to include the direction and magnitude of the object. Now, I'm going to talk you through several example problems.
Example 1. You have a car with a mass of 1,600 kilograms. The car is going at a velocity of 25 meters per second. What is the momentum of the car? So I've written the equation for momentum at the top. So all we have to do now is sort of insert the numerical values. So it goes as follows. 1,600 kilograms times 25 meters per second, which equals 37,500 kilograms times meters per second. For exercise 2, you have a ball that is moving with a momentum of 14 kilograms times meters per second with a velocity of 6 meters per second. What mass is the ball? You set 14 kilograms times meters per second equal to 6 meters per second times x, x being the unknown variable of the mass. Then you divide the 14 by 6. This means the mass is 7/3 kilograms.
Now, momentum can get a bit more complex. The law of momentum is very important. The original momentum is equal to the final momentum. Basically, the equation is Pi equals Pf, I being initial and F being final. In most general collisions, one object will lose velocity while the other one gains velocity. The best way to go about problems such as this is to create a T diagram with before on the left and after on the right. You're going to calculate the momentum for both the objects for before the collision and then add them together. Do the same for the after as well. Set both sides equal to each other and solve for the variable. In several situations, the two objects might stick together. In this case, just add the two masses together for the after section. Now, we're going to solve a few questions together.
Example 1. You have two teams that are playing a game of football. Player 1 is 130 kilograms and is moving at 4 meters per second. Player 2 is 90 kilograms and is moving at 6 meters per second. After player 1 tackles player 2, they move together. What is the velocity that they're going at afterwards the collision? So we're going to start with the before chart, and I have the equation for momentum written out. P equals m times v at the top. So for player 1, it's 130 kilograms times 4 meters per second. This will equal 520 kilograms times meters per second. Now for player 2, it'll be 90 kilograms times negative 6 meters per second. Now, the velocity here is negative because the player is moving in the opposite direction of the other player, as you can see in this little diagram I drew at the top here. This equals negative 540 kilograms times meters per second. Now we're going to add up the two results. 520 kilograms times meters per second plus negative 540 kilograms times meters per second equals negative 20 kilograms times meters per second. This answer is the momentum for the initial part of the equation. Now we're going to do the after, and it says that after player 1 tackles player 2, they move together. So we're going to add up the two masses, which will be 130 kilograms plus 90 kilograms, which is 220 kilograms. And when we put this in the equation, it will be 220 kilograms times x being velocity. So, and this equation right here is the final momentum. So, if you remember, final momentum equals initial momentum. So we're going to set up 220 kilograms times x equals negative 20 kilograms times meters per second. And we're going to divide the negative 20 by 220. So our answer will be negative 2 over 22 meters per second. Example 2. There's a car that is 1,000 kilograms moving at 15 meters per second towards a crate that is at rest. The car hits the crate. After the collision, the car is going at 14 meters per second and the crate is moving at 4 meters per second, both in the same direction. What is the mass of the crate? Now I do have the momentum equation written at the top. So we're going to start with the before now, and we're going to plug in the variables for the car, which will be 1,000 kilograms times 15 meters per second, which will give the car an initial momentum of 15,000 kilograms times meter per second. Now for the crate will be x times 0 meters per second, which will just be 0 since it is at rest, making the initial momentum of the whole system 15,000 kilograms times meters per second. Now we're going to move on to the after. So the car is still 1,000 kilograms, but it's now going at 14 meters per second, which makes the final momentum of the car itself 14,000 kilograms times meters per second. Now, the crate is now going 4 meters per second, which will be 4 meters per second times x, since we still don't know its mass. The final momentum will be 14,000 kilograms times meters per second plus x times 4 kilograms times meters per second. So we're going to set these two equal to each other. Now we're going to subtract 14,000 kilograms times meters per second from the 15,000 kilograms times meters per second, which leaves us with x times 4 meters per second equals 1,000 kilograms times meters per second. Now we're going to divide both sides by 4 meters per second, which leaves us with x equaling 250 kilograms. So the mass of the crate is 250 kilograms.
Those questions are basically what you're going to get when you're doing momentum questions. So as long as you follow the methods that I outlined, you should be good. This has been Physics and Fun. Can't wait to see you next time. Thanks!